Hi everyone, my name is Fabiola and today I'm going to be teaching you about recursion. And so just to outline what we're going to be learning today, we're going to learn what is recursion, then see an example of a recursive program, and then we're going to give you a coding exercise when you're going to be able to apply recursion. And of course, we're going to provide you with a sample program for this exercise. So when is recursion used? So sometimes a problem is too difficult or too complex to solve because it is just too big. And so if the problem can be broken down into smaller versions of itself, we may be able to find a way to solve one of these smaller versions and then build up a solution to the entire problem. However, the rule here is that if you can solve a problem using recursion, it can also be solved using iteration and vice versa. If a problem can be solved using iteration, you could apply recursion, but it depends. Sometimes one method is easier than the other. And so what exactly is recursion? So recursive algorithms break down a problem into smaller pieces, which you either already know the answer to some of the pieces, or you can solve some of these pieces by applying the same algorithm to each piece. And then at the end, you just combine the results. So more concisely, it is simply the process by which a function calls itself. And so just to outline what a recursive function usually looks like. And so recursion involves the use of a function that calls itself repeatedly. And so it has to involve some termination condition that when it's met, the recursion ceases. Otherwise, your function would go on an infinite loop calling itself over and over again. And so the general format of a recursive program involves two parts. The base case, which returns a value without making any subsequent recursive calls. So that's basically the end of the recursion. That's when you stop so that it doesn't keep going on a loop. And then the reduction step, which is the central part of a recursive program. And you'll see just in a minute what I mean by a reduction step. So now we're going to see a sample recursive program, and we're going to use it to reverse a string. So here we have this program. It's very simple, as you can see. First we have the main method, which takes in as an argument a string that you'll input in the command line. And then it just calls this function called reverse string, which is the actual recursive method in this program. And so the first thing we have is what we were talking about previously, which is the base case. And so when the string is empty, we're just going to return whatever we have. We're going to return the string. And so then it's the actual recursive part of the program in which the program, as you can see, calls itself. And so what does it call itself with? It calls itself with the string, but starting at the index 1. And so if we call it, for example, with the word code, in the first execution of this method, it will call itself with ODE, because C in code is in the index 0, and so O is in index 1. So it'll call itself from O onwards. And so it calls itself, the string is still not empty because you still have ODE, and so it calls itself again at index 1. And so now index 1 is D. From index 1 onwards would be D and E. So that's what it calls itself with, as you can see here. And then it calls itself again. The string is still not empty. You still have D and E. So it calls itself again, but again with the index, starting at index 1. And so what is index 1? It's just E now. That's all, the only thing we have left. So it calls itself again. It is still not empty because we still have E. And so we call itself at index 1. And so now index 1 would be just basically an empty string because after the E, we don't have anything. And so when you finally call reverse string with an empty string is when it will execute what's inside the if statement, and it will return S, which in this case is just an empty string. And then it will go backwards from the last time you called reverse string to the first time that you called reverse string and return s.substring starting from index 1. So we'll look at a trace so that you get a better understanding of what I mean by this. But the end result of this reverse string returning s at substring 1 in the backwards order in which you called it will eventually be the reversed string, EDOC. So we're going to look at a trace for the program so that hopefully you can get a better sense of what's going on. And so the first time you call reverse string is with the word code. Then the second time is when the reverse string method calls itself for the first time. And so it calls itself with ODE because it calls itself starting at index 1 of code and so on. Then it calls itself with DE because it calls itself starting at index 1, then with E because that's the index 1 of DE, and then an empty string because after E we don't have anything, so that would be the first index. And so once it reaches this return statement with the empty string, it will actually execute all the return calls that it had done in these prior calls to reverse string, and at the end it'll just output the reverse string, which is what we want. And this is the only thing we actually see in the output. These other things we won't actually get to see. That's kind of like the magic of recursion. So now it's your turn. You have learned what recursion is, you have learned when it is used, and then you have seen how it can be implemented. And so you're ready to write a recursive program on your own. So we're going to give you the prompt, which is to make a drawing using recursion. And you could be as creative as you want with this, but we're just going to give you a sample program of what this could look like, just so that you can get an idea of what you could do yourself. And so the sample program is very simple. It basically just draws circles, smaller and smaller circles. And so first it takes in from the command line an integer n, which is basically going to be the number of times the recursive function is going to recurse. And then it takes in a double, which is the radius, which is just going to be the radius of the starting circle. And then that's when it actually calls the recursive function, which is called circles, which takes in as arguments n and radius. And so here we have the base case, which is when n equals 0, you return, right? Because otherwise, you wouldn't really have anything stopping the function from calling itself repeatedly over and over again. And so this if-else statement is just so that you can visualize the different levels of recursion. So basically when you're on an even recursive call, it's just going to draw the circle light blue, and when it's in an odd one, it's going to draw it yellow. And so you're always going to draw a circle centered at 0.5 with the radius. And so the first time it draws a circle, it's just going to draw it just with the radius that you give it in the command line. And then it's going to call itself. You're going to do n-1 so that each time it calls itself, n is decreasing until you finally reach 0 and it stops. And then you're just going to divide radius by 2 so that each time it calls itself, the circle gets smaller and smaller. And so just so that you can see what this looks like, it looks like this. So very, very simple program. So I hope that you guys now have a better understanding of what recursion is and that you guys have fun doing this exercise. Thank you.